Today we have a challenge. We are going to develop and deploy a virtual kubelet in just 5 minutes. Before doing that, let's take a look at what a virtual kubelet is. So usually you have a Kubernetes cluster with many physical nodes, and each one of these nodes is capable of running a container on their own container runtime, so local container runtime, meaning containerd, Docker, kata containers, whatever you want. The concept of virtual kubelet is, okay, I'm going to deploy a kubelet that instead of running on a physical node with a local container runtime, it's indeed translating the instruction coming from the API server, from the core, if you want, from the brain of Kubernetes, into something else, into any kind of custom command you can imagine that is able to manage a container lifetime, meaning create my container, stop my container, give me the status of the container, and eventually the logs of my containers. There are then bonus tracks like let me attach my session to the container running and so on and so forth. We are lucky enough to have an interface already built for it. In fact, Virtual Kubelet is a sandbox project of the Cloud Native Computing Foundation. Some providers are already moving to this idea where they keep Kubernetes cluster just for its brain and then rip off anything else below Kubelet. So I know how to run your container in a proper way on my infrastructure. I give you the gate to my infrastructure as a Kubernetes API, and then from there, you're my guest. You know what I mean? You mean that Fly.io, take a look at this article, it did exactly that recently. So we are great in running containers inside MicroVM. That's cool. It's all you get from us. You will have a cloud interface as a Kubernetes cluster. So what we did with interLink was to introduce a layer between the whole internals of Kubernetes and the remote providers. We are going to set up a virtual kubelet on a MiniKube of our own on our laptop, and we are going to extend it to a remote machine, in this case a Civo.com machine with GPU, and make it connect to our MiniKube. I'm going to work on my local setup, and then whenever I need a GPU, I send my job to the remote machine with a Docker engine running on that. So brace yourself and let's get started.
First of all, you can find everything we are going to do into this documentation. I'll leave you the link in the description, and you can find everything from the API description to the very detailed commands that we are going to showcase today. Let's start from the configuration. So here you have different fields that are needed to configure your interLink setup, starting from the interLink URL and port, and then also the version of the software that you want to install. Then there is the name of the virtual kubelet that you want to give, and also where the installation will be in terms of namespaces. Eventually, you have also the possibility to specify how many resources will appear for that virtual kubelet. The last part is the most important, I would say, that is the OAuth authentication between your cluster and the remote counterpart. Now let's dive into the creation of a machine in Civo.com. You can see that everything is simple as taking my web UI and asking for the creation of a machine with a GPU, A100 NVIDIA GPU. I name my machine interLink, and that's all. It's all it takes. Create a machine and wait for the creation. Once done, you have a public IP that you can connect to with your private key. Right. Now, the only thing that you miss is to insert the public IP into the correct position in the configuration file, and we are ready to set up everything using the command line that you can download from our website, and starting the authentication procedure with GitHub. So this will retrieve your identity, your token, and forward this to the correct place into the deployment of an interLink. And as you can see now, as done, you have step-by-step instruction to be executed, starting from applying the Kubernetes relative stuff and making appear a virtual node here. So you see that these pods are doing what the supposed to do. So they are contacting the Kubernetes API server and say, hey, I'm a node lying about the fact that it's real, so I'm a fake node that it will forward the request to a remote site. Remote site that is not yet in place, so you will get a connection refused. Now we are going to set up the remote machine. We are connecting to Civo and installing all the needed pieces of drivers and NVIDIA Docker, just to be able to showcase that you can actually run containers with GPUs as a remote pod here. I'm fast forwarding here just for the sake of time, because there is nothing new to do. It's all well documented in Civo and in whatever NVIDIA or Docker. And eventually we will be able to run a container with NVIDIA SMI and see that the GPU is in fact connected to our machine. Nice, tidy, that's all we need. Now we can go back to our installation script, take our instruction, send the script for the initialization to the remote site, and just like that, getting ready to roll. So we enable the execution of the script, and we just need to drop a command to install all the components, certificates included, and then starting the daemons with start command. And now you will see that we start listening to the ping of the remote counterpart on the above, and here it is. Yeah, a first ping arrived to the interLink API server, and we are capable to see that arriving and everything is working. So the two parts are talking to each other. We just need to bring up our plugin. The plugin, in this case, we received the request from the interLink API server and translate that into Docker run into an NVIDIA runtime. You can download a fully functioning example from the link I'll let you in the description, and you just need to install pip packaging and some additional stuff that are all in the documentation, so starting from the fast API packages and the Docker Python bindings. Once done, you're ready to go, so download the Python example and then just add a few lines to enable the GPU execution. That's all it takes to start running any kind of machine learning workflows on your remote machine. All we have to do now to demonstrate that I'm not lying to you is taking a pod, normal pod, and select the my Civo node as a target for this pod. Then I'm bringing up the web server for the plugins and apply the test pod. You see that the request is coming and the plugin says, okay, I'm executing this container just like you request. And we see that it takes just a few seconds to appear as completed in Kubernetes and return a very nice log with what we expected. So the NVIDIA A100 appearing into the description. So that's pretty much all, right? So we can check that actually there were a container running on the remote host, but nothing more than that. So if I do docker delete, eventually it will also do docker rm of the container. So that's all, guys. I hope you enjoyed this. Stay tuned for more examples on how to use this kind of technologies to improve your data science daily life experience. Don't forget to subscribe and see you on the next video.